Hi there, this video is on section 4.5, which is law of cosines. We are continuing with solving triangles, and we are also going to talk about area of triangles. So remember, in section 4.4, we use the law of sines in order to solve what we referred to as case 1 and case 2, which the different cases, remember, are describing our name that we're putting to when you're given certain information about a triangle. So case 1 was whenever you know two angles and a side of a triangle, and then you're solving for the other angle and sides. And then case 2, remember, was that pesky ambiguous case, the SSA case, which you can also remember it's the ambiguous case by it's the ASS case, where there could be 1, 2, or no triangles that exist based on the given information. So now we're looking at the remaining two cases. So when you're given side, angle, side, and when you're given all three sides of a triangle. And we're using something called the law of cosines. Now, this is the way the law of cosines is written in your textbook, and it makes it seem like it's 3 different formulas that you have to memorize, but it's not. Notice that in each of these formulas, the side that's being squared on the left-hand side here is opposite the angle that you're taking the cosine of, okay? And then the other sides follow the same pattern of it's the other side squared plus the remaining side squared minus 2 times each of those sides, then times cosine of the angle. So these really represent the same formula. And so it's not 3 different formulas that you have to memorize, but you do need to memorize what the law of cosines is, and that should be pretty easy just by using it. Okay, so we're going to look at our first example. Just like before, I like to draw just a sketch of a triangle, not like not an accurate triangle, but I like to draw a sketch of a triangle and label it. Part of the reason is I'm not going to tell you what case you're dealing with when I give you information on an assessment, and you'll need to figure out which case it is and whether or not you need to use law of sines or law of cosines. Which you'll notice with this case, which it looks like this is the side angle side case, that you cannot use law of sines to solve for your first unknown. Like, you're stuck. You can't do it. So we have to use the law of cosines. Okay, so it looks like we are given that side B is equal to 4.2. Side C is equal to 1.8. And angle alpha is equal to 35 degrees. Okay. So we need to solve for beta, gamma, and side A. Well, think about this. Law of sines, we would need to know an angle that's either opposite. Like, if we wanted to solve for side A, we would need to know either beta or gamma. If we wanted to solve for either beta or gamma, then we would need to know what side A is. So you get stuck. You cannot use law of sines. Okay, so why don't we go ahead and solve for side A so that we have all 3 sides. And law of cosines, remember, is A squared. So I know it's going to be cosine of 35 degrees on the right-hand side. Now, since it's A squared and we are solving for A, I'm just going to go straight to writing this as A equals to the square root of B squared plus C squared minus 2 times B squared, 2 times B times C times cosine of 35 degrees. Okay, that represents, you could simplify it a little bit, but that represents the exact value of A. Okay, and this is enough. You don't need to simplify different pieces that are underneath the radical for me. This represents the exact value of A. So just type this entire thing into your calculator. and you should get an approximation of 2.915. Make sure you store, because we're going to need to use that exact value of A. So make sure it's not the decimal that you have entered, or you can hit second enter to pull up the entry again, and then store the exact value of A under a letter on your calculator, and maybe make a note in your work. Okay, so next I can solve, it doesn't matter, I can solve for beta or gamma. I'll just go in order, and I guess I'll solve for beta, angle beta next. So that means that I'll have side B, so 4.2 squared equals to A squared. Now, I don't want to write out that entire complicated expression that represents the exact value of A. So I'm just writing A in order to represent the exact value of A. And I've stored A in my calculator, so when I do type A and what the exact value of A is into my calculator, I don't have to type that complicated thing, and I can just call up the letter that I had stored it under. Okay, so A squared plus C squared minus 2 times A times 1.8 times cosine of beta. Okay, and we are solving for beta, so we need to get cosine of beta by itself and then take the inverse cosine. So we'll subtract by A squared on each side and 1.8 squared, and divide by negative 2A times 1.8. And then beta, I'm going to flip this, so beta will be equal to the inverse cosine of that ratio. Now the nice thing about inverse cosine is that inverse cosine will give us an angle from quadrant 1 or quadrant 2, meaning inverse cosine can represent an obtuse angle. So if this is an obtuse triangle, it will give us the obtuse angle. So typing this, making sure you're in degree mode, typing this represents the exact value of the angle beta, typing that into your calculator, storing it, and then hitting enter. The approximation is 124.253 degrees. Okay, now the reason that I reference the fact that it's nice that inverse cosine will give us an angle from quadrant 1 or quadrant 2 is that inverse sine, and remember this goes back to why we run into the issue of the ambiguous case for the ASS case, is the inverse sine of a positive ratio, which for when you're working in law of sines, you will only end up taking the inverse sine of a positive ratio, would give us an angle from quadrant 1, an acute angle. But inverse cosine will give us either the acute or the obtuse angle. So that's the approximation for beta as well as its exact value. You should have the exact value stored. So then to determine what gamma is, that'll be 180 degrees minus the sum of our given angle of 35 degrees in beta. And when you type that into your calculator, the angle is approximately 20.747 degrees. So I'm just going to highlight the approximations here. So side A, angle beta, angle gamma. Okay, and that was side angle side. We have another example of side angle side. Again, remember I like to sketch the triangle So gamma equals to 170 degrees. Side B is equal to 5. Side A is equal to 6. And we don't know beta, side C, or angle alpha. Okay, so we have to solve for side C. Side C is what we have to solve for first. So again, instead of writing C squared on the left, I'm going to write C equals the square root of A squared plus B squared minus 2 times A times B times cosine of 170 degrees. That's the exact value for C. Type that entire expression into your calculator and you get the approximation of 10.958. Make sure you store the exact value under a letter on your calculator so that you can use it for the next step of solving for, why don't we solve for alpha? We'll just go in order. We'll solve for alpha next. So if I'm solving for alpha, on the left side I'll have 6 squared equals 2b squared plus c squared. And I'm just writing c to represent the exact value of c since I have that stored in my calculator. So minus 2 times 5 times c times cosine of alpha. Okay, so subtracting 5 squared and c squared from both sides, dividing by negative 2 times 5 times c, and then I take the inverse cosine. So alpha, if you need to write out those steps, that's fine, or you can go directly to the fact that alpha is equal to the inverse cosine of that ratio. 6 squared minus 5 squared minus c squared divided by negative 2 times 5 times c. That's the exact value of alpha, and store it in your calculator. The approximation is 5.456 degrees. And beta will end up being equal to 180 degrees minus the sum of the given angle plus alpha. And alpha represents the exact value. Typing into the calculator to get the approximation of 4.544 degrees. Okay, side, side, side case. So you know all three sides and you are solving for all of the angles. So side A, so alpha, we don't know alpha, gamma, or beta. Side A equals to 5. Side B equals to 7. Side C equals to 8. Doesn't really matter the order. Now, your textbook, if you look at the examples in the textbook, Cynthia Young uses law of cosines to solve for the largest angle and then switches to law of sines. That's not wrong, but you have to be very careful if you do that, and I do not recommend that you do that. My suggestion is if you use law of cosines, so if you're dealing with case 3 or case 4, stick with law of cosines. You will be able to find the correct triangle every time, but every year someone prefers to do it the other way and go against my recommendation of switching to law of sines. If you are somebody that wants to do that, you need to make sure that you solve for the largest angle, so the angle that is opposite the longest side. The reason that you need to do that is if you switch to law of sines, let's say the triangle is actually an obtuse triangle. If you switch to law of sines without having solved for that obtuse angle first, inverse cosine will only give you an angle from quadrant 1, an acute angle. So you will not have solved for the correct triangle if you switch to law of sines without solving for the largest angle first. And it's a toss-up. Sometimes you get lucky and the triangle actually didn't have an obtuse angle, but sometimes it does. So my suggestion, though, again, is once you are in law of cosines, stay in law of cosines. I know it's a longer formula, but you will get the correct angles and sides every time. Okay, so I'm just going to go in order here, solve for alpha first. So setting up law of cosines to solve for alpha, I'll have 5 squared on the left equals 7 squared plus 8 squared minus 2 times 7 times 8 times cosine of alpha. So alpha will be equal to the inverse cosine of 5 squared minus 7 squared minus 8 squared divided by negative 2 times 7 times 8. Store that in your calculator. That's the exact value for alpha. And when you hit enter, that's approximately 81.787 degrees. Okay. And then solving, oh, whoops, no it's not. I was looking at the wrong one, sorry. Alpha is actually 38.213 degrees. Okay, so that's alpha. Now, if you were somebody that was trying to switch to law of sines after you solve for that first angle, you would want to solve for angle gamma first, since that would be the angle opposite the longest side. Okay, so now I'm going to solve for beta. So beta, oops, not beta. I'm solving for beta, but I would have on the left-hand side 7 squared equals to 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of beta. So beta equals inverse cosine of 7 squared minus 5 squared minus 8 squared divided by negative 2 times 5 times 8. Store that in your calculator. And beta actually, oh, let me double check this actually. Is 60 degrees. Exactly 60 degrees. So actually 60 degrees is the exact value. And then to solve for gamma, and you didn't have to go in this order for the angles. I'm just going in order to make sure it's easier for me to kind of make sure I'm solving for what I should be solving for. So 180 degrees minus the sum of the other two angles. So minus alpha plus beta, or you can write alpha plus 60 degrees. And gamma ends up being equal to 81.787. Sorry, that's the angle that I wrote earlier. I did all of these already so that the video wasn't longer with me having to type in values in the calculator, but okay, so those are the approximations highlighted, well, and one of them is an exact value. Okay, we'll do one more example of the side case. So again, we're solving for all three. Oh, that's not beta. That's gamma. That's beta. Okay. Now, if you were wanting to switch to law of sines after solving for that first angle, you should solve for gamma first. And we can go in the reverse. Let's solve for gamma, then beta, then alpha here. Okay, so if we're solving for gamma, we'll have 12 squared on the left-hand side equals to a squared plus b squared minus 2 times a times b times cosine of gamma. So gamma equals to inverse cosine of 12 squared minus 6 squared minus 9 squared divided by negative 2 times 6 times 9. Store in your calculator, and you should get approximately 104.478 degrees. Okay, so this is one if you did not solve for the largest angle first and you switched to law of sines, you would not have solved for the correct triangle. Okay, so let's do beta next. 9 squared equals to a squared plus c squared minus 2 times a times c times cosine of beta. So beta is equal to inverse cosine of 9 squared minus 6 squared minus 12 squared divided by negative 2 times 6 times 12. Store in your calculator. Beta is approximately 46.567. And then alpha will be 180 degrees minus the sum of those other two angles. Alpha is approximately 28.955 degrees. Okay, if you are interested in your textbook, when you have a side angle side, when you know a side angle side and you need to find the area, the textbook has a list of formulas. That list of formulas is really just based on your good old formula for area of a triangle, which if you remember back, I don't know, maybe elementary school, is area equals to 1/2 base times height. So let's, for me, the picture really helps here. And this is not going to be an accurate picture. It is just a sketch to kind of get an idea of where, what I am given and what I might need to solve for. Okay, so gamma is 86 degrees. Side A is 7 feet. And side B is 9.3 feet. Alpha, beta, side C. Okay, so we need to be able to determine the height in relation to the base. Now the thing is, the way that we have the triangle drawn right now, well, we don't know alpha or beta. And if we wanted to treat C as the base, we would need to solve for C. But we could rotate the triangle. So I'm gonna, let's see how this works. So I'm gonna copy and paste and rotate. Okay, and then I'll relabel this. So I rotated in the clockwise direction. Okay, so now this is side alpha. This is side gamma. probably an easier way to do this. This is side beta, side C. I could probably just flip it around. Will that work? There we go. About side A. Okay, so by doing that, I can now treat side A as the base. I'm going to treat A as the base. So 7 is equal to the base. It's going to bug me that that's not straight. There we go. Okay. Now the height, if side A is the base, the height H would be the length of that line there. Okay. And notice that I've created 2 right triangles. If I focus on just the right triangle on the right side here, then I know the angle gamma, and in order to solve for the height, I can use SOHCAHTOA. Okay, so since I'm solving for the side opposite and I know the hypotenuse of that right triangle, I'm going to use sine of 86 degrees equals to the height over the hypotenuse. So the exact value for H would be 9.3 times sine of 86 degrees. So that's the exact value of the height. And then we can plug that value in. We know the base. So the area of the triangle would be 1/2 times the base, which is 7.0 feet, times the height of 9.3 times sine of 86 degrees. And we can type that into the calculator and we get approximately 32.47 feet. Why did I only round? Is that 471 feet squared? Okay, so this would represent the exact value of the area, and then 32.471 feet squared is the approximation. Okay, now for side, side, side. When you know all 3 sides of a triangle, you can use something called Heron's formula, which, if you have Heron's formula memorized or you have it programmed into your calculator, which I'll try and find the program and share it with you, so if you want to put it into your calculator, you can, then the area of a triangle, when you know all 3 sides, is equal to the square root of S times S minus A times S minus B times S minus C. And you're probably like, well, what is S? Well, S is the sum of all 3 sides divided by 2. Okay? Or you can use good old-fashioned area equals to base times height, where I can, again, not an accurate triangle, I'm just for labeling purposes. Okay, so I'm going to treat side C as the base, meaning this line right here would represent the height, okay? And that creates two right triangles. So we would need one of the angles, so either alpha or beta, in order to determine what the height is. And it doesn't matter. I'm gonna find angle beta. Okay, so if I'm finding beta, that's 6 squared equals to 5 squared plus 9 squared minus 2 times 5 times 9 times cosine of beta. So beta is inverse cosine of 6 squared minus 5 squared minus 9 squared divided by negative 2 times 5 times 9. And store that in your calculator. And the approximation of that would be 38.942 degrees, although we don't really need the approximation. So if we are solving for h, you could use sine of beta equals to h over 5. So h would be equal, the height of the triangle would be equal to 5 times sine of beta. So area would be equal to 1/2 times the base times 5 sine of beta, and you should have beta stored in your calculator. And when you type that in, you get approximately 14.142. There are no units on this, so units squared. Now, if you were using Heron's formula, you'd see you'd get the same thing. So if you're using Heron's formula, you would need to figure out what S is. So S would be 5 plus 6 plus 9 divided by 2, which is 10. So the area would be equal to the square root of 10 times 10 minus 5 times 10 minus 6 times 10 minus 9, which is approximately 14.142 units squared. Which that's, I mean, it's just another formula to memorize. If you can memorize it, that's great. It's actually probably the most efficient if you were to see it on a standardized test to have it programmed into your calculator, so you could just